Hi, good morning. This is Mallikarjuna, Associate Professor, Adi Shankara College of Engineering and Technology, Guru. Today, I would like to discuss about lasers. So, laser is an acronym for light amplification by stimulated emission of radiation. So, laser light is a optics phenomena like electromagnetic resonators and amplification by amplifier and oscillators, and stimulated emission is atoms, molecules, and quantum physics, and radiation physics by non-equilibrium thermodynamics. So, some of the contents of laser: introduction of laser, principle of laser, kinds of laser, construction and working of helium neon laser, ruby laser, semiconductor laser, carbon dioxide laser, yttrium, barium, that means OA-NAG laser, and europium chelate laser, and rhodamine 6G laser. So many lasers are available in the markets, different type of applications. Applications of lasers by medical applications, industrial applications, communication applications, military applications, scientific and chemical applications. So laser is a light amplification by stimulated emission of radiation in era of 1939s. The microwave amplification by stimulated emission of radiation, Einstein in 1917s, it explains the laser light. Ruby laser, the first demonstrated by Myman in era of 1960s. Helium neon laser is Holly Javan in era of 1961. Diode laser is all in 1962. But some of the introduction, the word laser is an acronym that stands for light amplification by stimulated emission of radiation. Laser are essentially high directionality, high monochromatic, high intensity, and high coherent optical sources. Stimulated emission was postulated by Einstein as early as in the 1917s. In 1960s, a solid-state ruby laser is developed by A.H. Myman on this principle. In 1961, a gas-state helium neon laser was developed by Ollie Javan and others in Bell Telephone Laboratories. What is the difference between a normal light and laser light? So normal light is always in, it is not a coherent, it is not a directional, and it is not a monochromatic light. The intensity of light is very less. The angular speed is a more angular speed. The radiations are a polychromatic, and examples of sunlight, mercury vapor light from the diagram. And laser is always in high coherent, more directional, and more intensity, and monochromatic. The angular speed is very less. The radiations are monochromatic. Example is helium neon laser, ruby laser, CO2 laser, and etc. Characteristics of laser: basically high directionality, high monochromatic, high coherence, and high intensity or brightness. So directionality is during the propagation of laser beam, its angular speed is very less. The beam occupies the less area. Hence, its travel along the direction through the longer distance. The angle of divergence of laser beam is expressed as pi is equal to arc by radius that is equal D2 minus D1 by S2 minus S1. So monochromaticity, the property of exhibiting single wavelength. Example, ruby laser 6943 angstroms and helium neon laser 5893 angstroms, semiconductor laser 8000 angstroms, and carbon dioxide laser is nearly 10,000 angstroms. For laser, delta lambda is equal to 0.001 nanometers. It is clear that laser radiation is highly monochromatic. The brightness is the directionality of the intensity of laser beam is very more as the brightness is very high. The laser is used for welding and cutting process. Then coherence is two or more waves have same frequencies and have same phase. The coherence is the two types, spatial coherence and temporal coherence. The basic principle of laser action, the interaction of laser light with a matter is responsible for laser action. When light ray travel through the medium, the three different processes occurred. They are absorption and spontaneous emission and stimulated emission. Absorption means the number of stimulated absorption depends upon the number of atoms per unit volume N1 and E1 state, the number of photons per unit volume of incident radiation. The incident radiation is incident radiation energy density UV. The number of stimulated absorption is directly proportional to N1, that directly proportional to energy density, that is equal to N1 B12 UV, where B12 is Einstein coefficient of absorption. By the statement of absorption, the ground level of atom absorb h nu of photon of energy and get excited to ground level to excited state. That the process is called absorption. And spontaneous emission is if an atom is already in the excited level of atom and returned back to ground level after completion of 10⁻⁸ seconds, the atom moves to one to the higher level to the lower level, a releasing of single photon of energy. That the process is called spontaneous emission. The number of spontaneous emission of radiation depends on the number of atoms per unit volume, E2. That the transitions is E1 state to E2 state. The number of spontaneous emission is equal to N2A21, where A21 is Einstein coefficient of spontaneous emission. Atom star is gives rise to atom plus h nu. The major principle of laser action occurs stimulated emission of radiation. The emission of process in which the atom excited level is brought down to the ground level. An external force before the completion is 10⁻⁸ seconds is called stimulated emission. That means if an atom is already in the excited level of atom, return to the higher level to the lower level, then occurrence some incident photon is required. A releasing of two photons, stimulated photons are emitted. That process is called stimulated emission of radiation. The transition emits a photon of energy. Delta E is equal to E2 minus E1. Then the frequency is equal to E2 minus E1 by H. So number of stimulated absorption of emission of radiation is equal to N2B21 UV, where B21 is Einstein coefficient of stimulated emission. Some basic differences of spontaneous emission and stimulated emission. The first I would like to discuss about spontaneous emission. The emission of the photon by each atom without any external force is called spontaneous emission. A light emitted through this process is called incoherent radiation. The net intensity proportional to the number of radiation atoms. Light resulting through the process is not a monochromatic light. It is the less directionality. Light from sodium lamp or mercury lamp are used. It is proposed by Bohr. And stimulated emission is the emission of two photons by an atom when it is present at excited state due to action of external force is called stimulated emission. Light emitting through the process is called coherent radiation. The net intensity of light is proportional to the square of the number of atoms radiating light. Light resulting through the process is called coherent light. It is highly directionality and high monochromatic light. Light from a laser source. It is proposed by Einstein. That is Einstein. So, what is the population inversion? It is necessary to dominate a population of higher energy level is greater than the population of lower energy level. That is N2 greater than N1. The state of making the number of atoms more in the high energy level than the lower energy level is called population inversion. N1 greater than N2 greater than N3. The ground level of atom, it absorbs the H nu photon of energy, get excited to the ground level to excited states. And E2 is a metastable state, the number of atoms staying in the metastable state. If the population can be maintained in the metastable state, the atoms bombard with each other, and some sparkling of light comes out to the partial silver coated reflector. That light is called the laser light. The process of sending the atoms from E1 to E2 to get population inversion is known as pumping. The pumping mechanism is the atoms get excited to the ground level to excited state. This is known as pumping process. The pumping mechanisms is basically optical pumping, electric discharge pumping, inelastic atom-atom collisions, and chemical reactions. Optical pumping, best example is ruby laser. Electric discharge pumping is argon ion laser. Inelastic atom-atom collision is helium neon laser, and chemical reaction by HF laser. But basic construction and components of laser system. The laser system has three important components: energy source, active medium, optical cavity or optical resonator. So energy means it is like a xenon flash lamp, a krypton flash lamp, and electric discharge takes place. Active medium depends on the type of the crystal, type of the laser system. Like helium neon laser, the active medium is helium and neon. And ruby laser, ruby rod is a active medium, and etc. Another one side is a high reflection mirror, another side is a partial reflected mirror. That is called the amplification of light comes out to the partial silver coated reflector. The types of lasers among all the kinds of different types: solid state laser by ruby laser and NDYAZ laser. Neodymium laser means neodymium, yttrium, garnet laser. Gaseous laser is CO2 laser or helium neon gas laser. Liquid laser, europium chelate laser. Dry laser, methyl alcohol rhodamine 60 laser. Semiconductor laser is the best example of gallium arsenide or indium phosphorus, indium arsenide and gallium phosphorus lasers. So type of lasers, the emission of wavelengths. The lasers in argon fluoride is a visible light. It is a 193 wavelength in nanometers. Krypton fluoride 248 nanometers. Nitrogen laser 337 nanometers. Argon blue color laser for 488 nanometers. Argon green color laser 512 nanometers. Nearly 512 to 514 nanometers. Helium neon laser 543 nanometers. Helium neon laser red color 6338 nanometers or angstroms. 633 nanometers, 6330 angstroms. Rhodamine 6G laser nearly 570 to 650 nanometers. Ruby laser red color 694 nanometers. Yttrium aluminum garnet laser is a 10,640 angstroms. Carbon dioxide laser is 10,600 angstroms. So So different type of laser, their wavelength values like nanometers or angstroms. So construction and working principle of laser. Gaseous laser was invented in 1961 by Ollie Javan. It is a 4-level laser system. It is useful for the communication, like it is called medical application basically. So this is called the basic applications is medical applications, industrial applications, communication application, military and scientific and chemical applications. Lasers in medicine, it is also used in different applications like neurology. Another one is eye retina, and also used in different segments. For example, so lasers are used for treatment like plastic surgery and skin injuries. Lasers are used in eye surgeries, especially in detached retina. Lasers are used in stomatology to study the mouth and its diseases. Lasers are used in cancer diagnosis and therapy. Lasers are used in bloodless surgery. Lasers are used in kidney stones and gallbladders, the treatment of liver and lungs diseases. Lasers are used for the contract removal. So lasers application, lasers used in contract removal. Laser removes tissues from remaining the cornea to change its shape. It is a very important in eye therapy, and lasers is using for eye surgery, especially in detaching the retina, to apply the laser light from the retina system. And lasers are used in magnetic resonance image MRI scanning. Lasers in using eye treatment. Lasers are used in dentistry. The major advantages is no drilling sound, cannot be used on exciting metal fillings, and it is called used for the liver treatment, lungs treatment by using of lasers, and lasers are used in kidney stones treatment by laser, and laser tattoo removal. Laser beam breaks up the pigment in the tattoo to small particles. Then the body immune system attacks and destroy them. And thermal screening in COVID-19 pandemic situation to detect the temperature in the human body. Lasers in industry in the different segments, cutting, welding, and soldering purpose. A laser cutter, laser welding in different shapes, laser in heat treatment to cut the lasers to break the two pieces, lasers in government industries like lasers in 3D printing. Textile industries also used to laser textile stitching. Carbon dioxide lasers are used in designing in different type of modeling designs. Lasers in surveying and ranging, and lasers in communication, the communication between moon and earth, like different type of space communication purpose. And lasers are used in detecting the light detection and ranging, lidars, and also used to defense and sensitive areas at airports for communication across ATP segments, and NASA mass communication purpose, television purpose, lasers in barcode scanner, lasers in scanning purposes widely using, and lasers are using a different type of applications. Lasers in data storage in CD-ROMs, and lasers are used in diffraction phenomena, and optical discs. The optical disc is a form of removable storage. It includes CDs and DVDs and Blu-ray discs. Optical devices use a laser to read and write the data on the optical discs. The laser stands for light amplification by stimulated emission of radiation. Laser beam rides on the surface of the creating a small pit in the discs. These purposes are using the optical discs, laser disc drives, and different storage devices, CDs, DVDs drives, zip drives, and floppy disks, microwave disks, hard disks, etc. Lasers in holography and scientific research in laser spectroscopy, different type of Raman spectroscopy, typical Raman system, it like a diffraction grating by Ibjour colors, lasers in military, laser weapons. Do you expect me to talk gold fair, laser gun sights, and military purpose widely using of target laser tag for soldiers, laser targeting system, aircraft mounted, lasers guided bombs, smart bombs, laser targeting system, ground based system, the using of laser. And lasers are used in the different segments and chemical reactions. So it is lasers are used to laser particle size analyzer and analyze the biological cells also shape and size also analyzing in the help of the laser. Isotopic separation. These are all of the good applications in lasers in different fields. And thank you very much.